Hello, we're the senior design team, Cool Compressor Club, and this is what we have for you. Over the past 3 months, we have designed and built this mini split heat pump system for the tiny house project. Mini splits are gaining popularity for off-the-grid applications like at homesteading, RVs, and tiny houses. They move thermal energy of air around to heat or cool a building. They are almost all powered by AC current. And unfortunately, off-grid power generation is DC current. Common industry refrigerants are 54B and R332, and they have a global warming impact of around 400 to 700 times that of carbon dioxide. A previous team tried to modify this existing unit, but the systems control they weren't running properly without major modifications. So we set out to make a new system to solve the full problems of low GWP refrigerant with a low environmental impact, direct DC power without inverters, and custom controls, and this is how we solve the problem. So like most HVAC systems, we're utilizing a vapor compression cycle. Our system will be charged with refrigerant R124YF, primarily because of its low GWP of 4. This right here is our compressor. It is the main component of the vapor compression cycle, and it'll consume about 80% of the entire system's power. It is a master flux rotary style compressor and was picked specifically because of its coefficient map showed a 1 ton refrigerant capacity, and it also runs directly on DC power. The compressor will send the refrigerant to the thin tube heat exchanger. It will take the heat from these pipes and send it to the outside air with this fan. So the refrigerant will move through a filter dryer, which is right here, a sight glass, and a one-way thermostatic expansion valve where its pressure and the temperature will be significantly reduced. And then these check valves and the reversing valve will allow the refrigerant to flow backwards, which lets us change from heating and cooling mode. The refrigerant will flow through these pipes onto this other heat exchanger. The cold refrigerant from the expansion valve will enter and absorb the heat from the inside air, or in our case, water, through these pipes and right here. The water lines will heat or cool down the tiny house and fill the water storage tanks. Everything is controlled by this control box. We're using a Raspberry Pi as the main computer, and it'll handle all the logic. And then this circuit board is specifically for the compressor. It'll simplify everything to a single 5-volt signal. And then this here is the driver for the fan motor, and this will be the power supply that we're using for testing before attaching it to the off-grid solar panels. We have designed and made this multi-split heat pump, which uses a low environmental impact refrigerant, R124YF, and runs off of DC power, which will be provided by the solar panels, and made a custom control box for the unit. Thank you for learning about our senior design project.